What major software failures did null pointer exceptions cause? Imagine a tiny mistake causing a massive system crash that affects millions of users worldwide. That's what can happen when a null pointer exception slips through the cracks. These errors are common in programming languages like Java, where null references are frequent. They happen when code tries to use an object that has not been initialized or has been set to null. When this occurs, the program suddenly stops working, leading to crashes or unpredictable behavior. One of the most notable failures caused by null pointer exceptions happened in 2025 at Google. A null pointer exception in Google's service control system, which manages authentication and quota enforcement for Google Cloud APIs, caused a worldwide outage. The failure started because a policy update inserted a null value into a database field that the system did not check for. This small oversight triggered a crash loop across all regions, leaving millions of users unable to access services for hours. This incident shows how a single unchecked null value in critical infrastructure code can lead to a large-scale failure. Besides this major event, null pointer exceptions are a common cause of runtime crashes in many software systems. In languages like Java, they happen when code tries to call a method on an object that is null. This causes the program to terminate abruptly or behave unpredictably. In large applications, these crashes can cause service downtime, data corruption, or even security vulnerabilities if not handled properly. In lower-level languages like C and C++, dereferencing a null pointer can cause segmentation faults or undefined behavior. These issues are often harder to debug and may lead to crashes or corrupted program states. Debugging null pointer issues can be tricky, especially when the program behaves inconsistently. Sometimes calls on null pointers succeed, depending on compiler optimizations or virtual function dispatch. To prevent null pointer exceptions, developers often use defensive programming techniques like explicit null checks before using object references. Validating external data sources such as user input, APIs, or databases helps prevent null values from propagating into critical code paths. Modern languages like Kotlin have built-in null safety features that reduce the risk of null pointer exceptions by design. Using thorough testing, including edge cases where null values might appear, is also essential. Feature flags can help control the deployment of new code that might introduce null-related bugs. Understanding what causes null pointer exceptions and how they can lead to major failures is key to fixing bugs effectively. By recognizing common scenarios that lead to null pointer exceptions and applying best practices for null handling, developers can improve system reliability and avoid costly outages.